All right, so first of all, I just want to take a quick moment to thank all of you for taking the time out of your day today to join our symposium and to contribute to MIMO's mission to accelerate the development and understanding of machine learning for manufacturing and operations. I also want to thank the Symposium Organizing Committee, made up of alumni and current students, for all of their efforts over the past several months that have made this event possible today. And just one final note, following Ujjwal's presentation, Bruce is going to come up and give some brief closing remarks and then an introduction to this evening's poster competition. So without further ado, let me give the introduction here. Ujjwal Kumar is the group president of Teradyne Robotics, an advanced robotics platform which includes universal robots and mobile industrial robots, the pioneers and global market leaders of human-scale, collaborative, and autonomous mobile robots. Ujjwal has a 25-year career spanning multiple industries and major multinational corporations, including General Motors, General Electric, and Honeywell. Prior to this role, Ujjwal was the president and CEO of Honeywell's Process Solutions and Business. Let's welcome Ujjwal to the stage for his presentation on reimagining manufacturing in the new age of AI and robotics.
Thank you. Hey, I realize that I'm the last speaker before the cocktail or whatever we'll have in the evening, so I'll keep it entertaining. I have few slides just to walk you through the big transformation which I have witnessed through my career. I feel that this whole industry 3.0, which when I started my career, I was so excited about, saying this is the big industrial transformation ongoing. It within a decade, it became industry 4.0. And I didn't even realize at what point it moved from 4.0 to 5.0. And here we are. So I have few slides just to walk you through how I see this industrial world transforming. And several of you who have run factories or run businesses which have made something, you will relate to the story I'll be sharing. So very basics. We are in MIT, so I needed to make it very schematic. You would realize a simple manufacturing process. It has product configuration, like you design something and some material is fed into a factory floor. And the manufacturing process has people, machines, and utilities. And the utilities itself has transformed a lot in my 2 decades. Initially, when we said utilities, we talked about power, some water. Now you have internet, fiber optic cable, like that. Utilities itself is going through the transformation. But people and machine is where I'll be touching on today. There is a huge transformation going on. And I'll start with the problem statements, which all of you, I'm sure, know about. On the product configuration side, you have increasing variability, shorter design, shelf time. You buy your iPhone today, you move from iPhone 7 to iPhone 8 to iPhone 9, like very quickly. You buy your car, there is a car model for every year. Any manufacturer out there has to continuously introduce new variations to differentiate, to survive in today's fast evolving marketplace. You have labor shortages and skill set gap, which has actually increased. In last couple of weeks, I traveled several countries in Asia. It was mind-boggling to see low birth rate and how quickly the demographics has completely changed. And this is a phenomenon in every part of the world. We don't have workers, and the workers we have, I don't know what the new generation wants to do, but they don't want to work in the manufacturing space. So we have a serious labor shortage issue in the short term, and a labor shortage really big issue, which is a big impediment to our economies moving forward in the long run. On the machine side, we have low efficiency, like all these machines. Just think of those industrial robots which have been around for 50 years. Those were supposed to drive the next generation of productivity, and they did. And again, when I was starting my career, those were the instrument for driving productivity. And now all of them, they are running at 40 to 50% capacity utilization at its best. You had everybody develop their best assembly line with the most automated cell for doing every activity. You're doing welding, screw driving, gluing, packaging. Everything was done in the most optimal way. And as soon as you change product configuration, that it's no more optimal. And over time, it gets less and less optimal. And our manufacturing floors of today, they need a different thinking, a different technology to take them to a decent, respectable productivity level. I spent my entire career in the large manufacturing space. In those of you who went to business school, everybody learned about this economies of scale. We all leverage that. You do the same thing at scale. You had a huge moat versus those small and medium manufacturers. And all those new levers which came, like Lean and Six Sigma, like I'm a black belt Six Sigma, I feel irrelevant now. All those tools came, it just made those larger manufacturers even more efficient. And it kept creating that moat versus the small, medium manufacturer till the game changed on those large manufacturers themselves. Where will you get economies of scale now when you had so many product variations? The economies of scale doesn't come just because you are big. Economies of scale come from what is that repeatable stuff you are doing at scale. No large company has that volume now. That economies of scale goes away, and that the biggest way in which most of the manufacturers, they leverage that economies of scale was on labor arbitrage, whether taking that volume, moving it to China, or taking it and moving it to an assembly line where you are using human beings more like a robot, doing the same thing in a very repetitive way rather than using their cognitive skills. That whole economic model is gone. The economic model I survived with, like I've been running global businesses for 15 years. I have used these advantages multiple times. And those same businesses I have to go back and run, I'll struggle to find the right tools. This is on the product configuration side, which has now created that great playing field. You're a large manufacturer, small, medium, you are in US or in China, you have great cheap labor, expensive labor, it does not matter. That whole world is gone. Like I was in China last week. There were more robots than people on almost every factory floor I went to. So now if we are using robots to do all that work, whether you do it in China or in US or in Timbuktu, it doesn't matter. The second one is this whole people and machine part. As I see this whole small, medium, whether you have cheap labor or not, that goes away. You need a way to address this labor shortage, which you have as an issue everywhere. You have to handle this low productivity going on on the manufacturing floor. And this advanced robotics which is different than the robotics which we know from last 50 years, the industrial robots. This industrial robots, Industry 3.0, all mechatronics based, about repeatability, accuracy. Advanced robotics is an Industry 5.0 solution, more software based, collaborative robots and autonomous mobile robots. These are designed for handling high mix, low volume the situation. And AI has come like a perfect marriage. The advanced robotics badly needed that software stack where the advanced robotics, every time they was going there to solve the problem of this new world, which is all about high mix, low volume, AI gives you a toolkit with which you can triple, quadruple your opportunity space. I'll just share a few quick examples of ways in which I see every day now AI becoming real. I think somebody in the previous panel was talking about it is all about what's real customer problem you're solving. And there are tons of foundation models out there, and Teradyne Robotics being the pioneer of collaborative robots as well as one of the biggest player. We also are the open platform. We also capturing on the input from one of the earlier panels. That world of I am big, I can develop all the technology myself, that was gone long ago. Now it is all about ecosystem. You have to find your strength, and if you don't embrace open platform, you may enjoy that black box benefit for a couple of years, but you'll be dead. There is the pace of innovation, the number of different technologies you need to solve a customer problem that has gone to a whole different level. So one of the key philosophy for Teradyne Robotics is this open platform concept, where we focus on just developing world-class robots, make it hardware and software open source for anyone to develop their hardware and software on top of it and make it their own. I'll just share a few examples. So this is with from Amazon. You might have seen this was released by Amazon 3 months back. They have been working on this problem for last, I understand, 4 years. They put best of the PhDs from different schools and also hired in-house. This is a picking and stowing problem. You go to one of the Amazon's warehouses, they store different kind of stuff in these bins. It looks like a shelf with a rubber band in the front. They take a ball, put there, a box, put there, a comb or whatever. Everything, next item is different. And that level of stowing and picking needs next level of cognitive thinking, which you cannot program. And they, for a long time, this was classified as a space which will never be done by an autonomous system. You will always have as a minimum human in the loop. And Amazon was able to solve this problem on the Universal Robot platform, and they announced it 3 months back. This is the Siemens example. If any of you were in Hanover Messe last week, like there were, I think, Norwegian president, the German chancellor, like there were multiple people. I don't know all the business leaders there, but they wanted to go and see a real life application of AI. And Siemens, working with a startup in Norway, they developed this AI-based solution, which is around leveraging different kind of languages to program something which will take you days, which you can program it in minutes. And this is leveraging the standard PLC platform, which everybody is used to. And Siemens' interest there is they are a big player in the PLC market. The NVIDIA announcement, you might have heard, we did this collaboration with NVIDIA. So what NVIDIA wanted to prove is, and they have been working on this for last 3 years, this is autonomous inspection problem. This is another place where human beings hate doing it, but there was no other way to do this work. What you do, you go to any of the any manufacturing facility where you have quality inspection done. There will be an individual who will come and see, okay, this is this part, this is the test, 20 different tests you have to do. You look here, take the measurement, are the screws in the right place? It's a super boring job. And those who have been on a factory floor, you would realize that that is one job you have where you have a very high churn. People come, they get frustrated because you will make a mistake like once a week. And those mistakes typically are very expensive. They, here in this example, what NVIDIA did was with one of the automotive manufacturers, you take these 20 parts, you just load the CAD drawing for all those 20 parts and the test procedure. Now the robot comes, it automatically recognizes this is part number 14. And in this part number 14, this is the test procedure, and this is the base location, and you start your measurement and inspection. Goes, the next one comes, this is part number 8. This is the test procedure. So you go to this next level of quality and fidelity on your inspection process, which immediately takes something which we as human beings will never be able to remember those 20 different parts, very similar looking, and going through those 20 checklists for each one of those, and doing it in a high quality way. Just let a robot do it. They always wanted a robot to do it, but there was no way to solve that problem before AI came into the picture. Oh, yeah, this is their video. I didn't realize it was a video. This is around programming. So this is a German startup. And you will realize every time we talk about any of the solution these days, you will have behemoth companies like Siemens and a startup and somebody all working together. This is the new world. Its size does not matter. It's multiple people from different walks of life and expertise need to work together to solve these kind of problems. So RoboMinds, they came up with this RoboBrain Vision Kit, and they are solving the problem of programming, where rather than coding for doing this is a logistics bin picking solution. So rather than teaching the robot that this is how you identify a particular object, you just let the robot go and learn it by itself. It first few times it will make mistake like any kid, but after a couple of hours of operation, it will be that perfect robot which will be able to teach the next robot. Like you go to one of the universal robot factories in Denmark, all our joints are made by another robot. When the first robot was coming out, we had a huge labor shortage in Denmark. Like it's a country of 6 million people. They needed someone to learn how to do that, the whole assembly of the joints, which is super complex. So the first person assembled it with sensors on the hand. And after that, a robot took over, and now we have more than 2,000 robots coming out of that plant with how many joints? Probably 5 joints each robot. And each of those are done by this another robot. You will not be able to get to that level of quality and execution without AI. This is the final one. This is the new product we launched on 19th of March. This is a pallet jack. So comes and lifts that packet. And you can see the product leader at the show in Germany. He was actually kicking the pallet to move it somewhere. Every once in a while, he'll move it somewhere else. In real life, these pallets don't look this neat. They are broken. They are painted in different ways. There are stickers on it. The people also do shrink wrap. So to a robot, an algorithmic robot, they get confused, saying, is this really a pallet? And the understanding a real pallet among million different configurations of a pallet, you cannot feed million different images. Now we feed around 20,000 images and videos. Beyond that, the pallet detection system, they learn by themselves. So these are some of the ways in which we were able to redefine the advanced robotic space thanks to AI. It made our robots more intelligent. It added a lot of new capabilities which we didn't know before. It is bringing humans closer to the robots. So you know the whole speech and as well as the emotions perception, which is helping these robots be at home, do elderly care. There are so many ways in which it is now being collaborative and being intelligent and being perceptive. It can actually help with something fruitful rather than just being that cool toy. And it is enhancing safety and reliability to the whole level. Like these collaborative robots, they don't need to be in a cage anymore, the way the industrial robots used to be. This is my last slide. We work and like our own robots, they are morphed in different ways by innovators in schools as well as at bigger companies and startups and innovators, all kinds. They put it on a rail, they put it on a skateboard, they put it on whatever different system, or they take one of our mobile robot and put things on top of that to innovate different kind of robotic solutions. And you have the whole spectrum. We think that the number of use cases which we could have solved with, even before AI, we have done less than 4% of that. So you have 96% of the applications still ready to be to move into a more intelligent robotic system as we have need. Like the biggest need we are trying to solve here is the labor shortage and that repetitive, dirty, and dangerous work which is still done by humans today. With that, I'll just say let's work together to drive this Industry 5.0. We are in this together. Any questions?
Thank you for a very nice presentation. I think of the large-scale robotic solutions for the back of the warehouse type of solutions. You thought of the smaller scale back of the store type of solutions. Do you have basically you thought about the application of this AI plus robotic solutions for the smaller back of the store type of operations, especially moving smaller pallets around?
Sure. So today, most of these robotic systems, 90% of our installation today, they are with small and medium customers. Remember, the large customers, they already had automation done by industrial robots because they had the volume. Now, as they don't have that repeatable volume, they are embracing something which was the biggest productivity tool for small and medium players, whether in warehouses or in manufacturing.
I see. Thank you. Appreciate it.
Sure.
Thank you very much for a very, very insightful talk. You mentioned about now moving the cobots out of the cage. I'm wondering about in your experience, what gave the industry the confidence to do that? And can you make analogies of that process that could apply to more highly regulated industries?
Sure. So cobots are already out of the cage. The industrial robots, the more mechatronics-based, those heavy robots, those were in the cage. This technology, when they were developed in 2008 by these students from Denmark Technological University, their whole concept was they wanted to create a robot which human beings feel safe to have them close to them, and a robot which is intelligent, so which will never harm other human beings. So we had limited, let's say, acceptance in early years, because people still thought, what are you talking about? Robots, they are all about doing things really fast. They have to be in cage. But over years now, you see there is a huge boom in this collaborative robot and the autonomous mobile robot space, primarily because now people see robot as not something where you invest millions. These things, they go for $20,000, $30,000 a piece. These a small business can buy and program themselves, and they can reprogram it, redeploy it. So it completely changes the equation of how manufacturing is done. It's no more big automation, 3 to 5 year ROI. This is 6 month to 1 year ROI solutions.
Thank you. A wonderful perspective. Yeah, well, it's great. I know there's a skill shortage in many, many areas, like beyond going to the manufacturing. What other major area, with due respect to this is Mimo, what other area is really the robots are extensively with AI is being deployed or used? And the second quick question is, what's next? So what is 6.0?
Sure. No, absolutely. So I would say the whole AI and robotics industry, it is still at the beginning of its real, we don't know what we want to be when we grow up. There are so many ways in which this whole industry will be disrupted. What we are calling Industry 5.0, it is still not a well accepted term. People still say it's Industry 4.0 Delta. AI is not fully scaled up in the industrial space. Now, in terms of application, we right now see really good adoption in the life sciences space, in hospitals. There is a version of this which is with human in the loop in the surgery space. There is a huge shortage of surgeons, and there is a very high exodus going on in the nursing staff. There is a really good adoption of AI and robotics in the surgical space. Every few weeks, I hear about some new way in which someone is using this technology to solve an old problem. And I'll just share one which intrigued me a few months back. The great coral reef off the coast of Australia. We have been losing, we have lost millions of hectares of coral reef because of our own human stupidity over the last several decades. There is a team of very committed environmental biologists who have been working on recreating coral reef for the last 10 years. They have done around, I don't remember the exact numbers, but around 7 to 8 hectares they have recreated in last 10 years. And now they have a technology through which, if there are more people volunteering, they'll be able to recreate it at a very fast rate. But remember, we have to recreate million of hectares which we lost. if you even double, triple, lot of people volunteer, they do 10x, they'll be doing 70 hectares, let's say a year. It'll still take us a long, long time to recreate that. So 10 months back, they're biologists, they're not robot scientists, but they heard about now anybody can program. And they actually bought a bunch of these universal robots and reprogrammed it. And now they have around 10 or 12 robots who are doing this work. They have done 5 hectares in 3 months. And now you can start using these robots to do the kind of work which was not humanly possible. And we as human beings really want to do it. So every few weeks, I come across these new ways in which our imagination at work to do something, some societal good.
Thank you, Ujjwal. Thank you very much.